This is the notes video for Chapter 3-1. We're going to start reviewing exponents as we make our way into working on polynomial expressions and multiplying them and adding them and different things here. So we want to refresh on our exponent rules that we have learned in the past. Today, our objective is to write and simplify expressions involving exponents. What you'll see, hopefully this looks familiar to you. We've got this on our page here. It's 5 times 5 times 5, and we know that that should equal 5 to the fourth power. Okay, so just some things to highlight here, right? We know that when we multiply something over and over and over again, we call that the expanded form. And when we rewrite it as 5 to the fourth power, our exponent is the little number up in, the superscript number. And then our base is the number that has the exponent attached to it. Okay, we call this the exponential form. Some things to remember about exponents. Okay, so the exponent tells you the number of times the base is used as a factor. So just a reminder that we are using multiplication. And when we have parentheses and exponents, we have to be extra careful. So let's look here at this one. It says 2y to the third power means, so when we're looking at this one right here, 2y to the third means what? Well, we're taking it and we're multiplying 2 times y to the third power. And remember, y to the third power simply means y times y times y. So if we were asked specifically, like, what is the exponent in this expression? Well, the exponent is 3. And the base of that exponent is going to be y, right? So our y right here is being raised to the third power. 2 is not being raised to the third power. 2 is simply to the first power. Now things change in the second example where we've got parentheses around the 2y and then our exponent is outside. So this one simply means that we're taking our base, which is going to be 2y, and we're multiplying it times itself 3 times. So that product of 2y to the third power means 2y times 2y times 2y. So in this case, our exponent, which is the 3, right, is of the base 2y. So the 2 is also included in the base on that one, and that is because of the exponents. All right, so we've got number 1 here, says write each expression in exponential form. So right now they are each in expanded form. When we see 6 times 6 times 6 times 6, we know that we can simplify that to 6 to the fourth power. Okay, and I guess I should hesitate to even say simplify it. It's just an easier way of writing 6 times 6 times 6 times 6. Okay, when we look at a times a times a times a times a times a, we are multiplying a times itself 6 times. So we can write our base as a and our exponent is 6. The third example for this one here, letter C, says negative 2 times x times y times 3 times x times y times x. Okay, now we can use our commutative property of multiplication and rearrange the order. Remember, that just means that if I change the order of the factors, I'll still get the same product. So in this case, I'm going to think of this as negative 2 times 3, because those are compatible. I can actually multiply those. And then I have times x, and I see here that I have 3 x's. So it's x times x times x. And then I've got 2 y's, so I'm going to say times y times y. Now it's still in an expanded form, so we can take it now and rewrite it as our exponential form. Let's multiply what can be multiplied. Negative 2 times 3 can be multiplied. That gives us negative 6. And then when we take our 3 x's and we multiply them together, we're going to get x to the third power. And then we have the 2 y's would be like a y squared. So our answer should be negative 6 x to the third y squared. Let's look at the next example. So example 2 says, find the area of the rectangle. So our area of a rectangle, we know, comes from multiplying the length times the width. And it doesn't matter which side is the length or which one is the width. I'm going to let my side that's labeled 3x be my length. So I'll write in here 3x. And then my side with just the x, I'm going to make up my width. So I have 3x times x. So when we think about multiplying those together, that's really like saying 3 times x times another x. Well, the shorter way to write that would be 3x to the second power. And if you wanted to check it, you totally could do that. If we give x a value, let's say that x is 4. So the length of that side is 4, and the length of this side would be 3 times 4, which we know is 12. So if I'm finding the area here, I know that this would be like saying length times width, and 12 times 4 gives us 48 square units. And if I took my expression here, I said that the area is also equal to 3x squared. Now, if I take that 4 that I plugged in for x, and I plug it in for the x in this expression, I'm going to have 3 times 4 to the second power. Now remember, that's like saying 3 times 4 times 4. So I want to do the 4 squared first, which is going to give me 16. And 3 times 16 also gives us 48 square units. So since we get that same product, we know that we are correct. Let's look at the second part of that example. We're going to find the area of this rectangle that has dimensions 5y and 2y. So again, remember, area is going to equal our length times our width. So our length on this one, we'll call that 5y. So we'll write that in here, 5y times our width, which is 2y. So our area is going to equal 5y times 2y, and we can take that and rearrange those, because since everything is being multiplied, we'd say 5 times 2 times y, which is going to end up giving us 10 times y to the second power. And that is the area. All right, example 3 says evaluate the expression if m equals -2. Now this isn't something new. We've been working on these a little bit already, but I want to make sure that when we are plugging in something and evaluating it here, we got to be careful, especially when it's a negative number. When I plug in this -2 for my m, I've already got a 4. And when I put that -2 in, I want to make sure I put it in parentheses. So this m that we have right here is being replaced by that -2. And then we still have this exponent out here. So this exponent, this 3, is on the -2. It is not on the 4. This is the same thing as saying 4 times -2 times -2 times -2. Now you don't have to expand it out that way. I just want to make sure that you're comfortable and understand what's going on. If I was to do -2 times -2 times -2, I know that these two would give me a +4. And then when I multiply that times -2, it gives me a -8. So I'm really looking at 4 times -8, and that's going to give us a -32. Okay, so that is our answer. Now let's jump back and look at the next example, which already has parentheses in it. It's got parentheses around the 4m, so our base is 4m. And after doing the examples we've been doing, right, we should know that this is going to be like 4 times -2, right, to the third power. Okay, well, order of operations states that we need to do our grouping symbols first, and what's happening inside our grouping symbols is 4 times -2. So let's pull out that negative 8, and it is now being raised to the third power. So this is like saying negative 8 times negative 8 times negative 8. Well, negative 8 times negative 8 is 64. And then when we multiply positive 64 times negative 8, we should get negative 512. And that's okay if you need to use a calculator to get that last little bit of it. Okay, so looking at 4, they're just going to ask us to simplify. So the first two, you see A and B, and this may not be written in the same order on your paper. You might see them written horizontally instead of vertically, but I've got these two problems look very, very similar. One has parentheses and one doesn't. And in fact, I'm going to look at B first. Right, when I look at B, I can see here that my base is negative 3. This is saying the same thing as negative 3 times a negative 3. In which case, we know a negative times a negative is a positive, and 3 times 3 is 9, so that would be our answer. But when we look at the top one, okay, we have a negative in there. However, when we don't have those parentheses, this is the way that it reads. It's like saying the opposite of 3 squared. So when you look at it, you're thinking about it's being a negative 1 times a 3 squared, which means the base is actually just 3. We're looking at negative 1 times 3 times 3. And when we do that, we should end up with negative 9. So our answers on this one aren't even the same. Even though they look so much alike, okay, they are not the same. For the first one, we get a negative answer. For the second one, we get a positive answer. The third one we'll look at, it has the quantity of 7 minus 3, and then it's being squared. And again, order of operations. We got to look inside of here first to simplify. 7 minus 3 is really just 4. And then since we have 4 squared, it's 4 times 4, which is just going to be 16. And the last one in this section looks very similar to the previous one. However, when our base was all of this in the last one, our base on this one is just the 3, right? So what we have is 7 minus, and our 3 squared is like saying 3 times 3. And so we end up with 7 minus 9, which gives us a negative 2. All right, so got to be careful with those. Got to follow the order of operations in order to make sure you're getting those correct. I added this one in. We didn't go through this one in class, but since it's in here, I'll go ahead and do it. It says evaluate. We have the expression 3r plus 2s, and it's all being raised to the second power if r equals 2 and s equals negative 4. So the first thing, let's just recopy it. Right, recopy it exactly the same, except for when we take out the r and we put in 2, we put it in parentheses, plus 2, and then in this case, we're going to have negative 4 in parentheses, and then make sure you get everything else. Don't forget anything. So now we just need to simplify down using order of operations. Looks like we have some multiplication inside our grouping symbols. So 3 times 2 is 6. 2 times negative 4 is negative 8. And then that's still squared. 6 plus negative 8 should be a negative 2. So we have negative 2 squared, which means negative 2 times negative 2, which is going to give us 4. All right, these ones you don't actually have to copy down. Maybe you want to pause the video and try to work through some of them ahead of time, and then you can kind of watch. We just stated the answers verbally in class. So on number 1, you'll see that we've got x times x times x times x, and we know that answer then would be x to the 4th. Our base is x, and it's being multiplied times itself 4 times. For number 2, you see a times a times a times a times a, which is the same thing as saying a to the 5th power. Remember, it's got to be multiplication. 3, if you haven't had a chance to do it, pause it, try it, and then you can check your answer. We've got an n and another n, which is going to give us an n squared. And then we have a y and another y, which is going to give us y squared. So we have the product of n squared, y squared. Remember, there's no plus in there at all, so don't write n squared plus y squared. That would not be correct. Number 4, we have c times y. With this one, when we do it there, we can take those c's and multiply them. We'll get c squared, and then we'll just have our y on the end. 5, we're incorporating some digits, right? So this is like 2 times 5 times p times p. 2 times 5 is going to give us 10, and p times p gives us p squared. So we get 10p squared. 6, when you try this one, you've got a times 3 times a times a times 2 times a, which is like saying 3 times 2 times a times a times a times a, which should give you 6a to the 4th. 7 can be tricky, but if we think about it, even if it was like numbers, if I do negative r times negative r, right, negative times negative is positive, and then r times r would be r squared. So we actually get r squared on that one. Now, a step you could take beforehand would be like a negative r in parentheses squared, right? But that still equals a positive r squared. For number 8, though, we have a negative r times a positive r, which is a negative times a positive we know is negative, and then r times r is r squared. So we actually get opposites between number 7 and number 8. Number 9, we have a negative 2 times a negative 4 times a b times a b. That should give us an 8b to the 2nd power. And these last 3 in this section, right, if you haven't had a chance to do them, make sure you pause it, try to work them out, and then see if you got them right or wrong. Here we go. This one I've got 2 times negative 4 times k times k times k. Well, let's multiply the 2 and the negative 4. That gives us negative 8. And then k times k times k can be rewritten as k to the 3rd power. 11, the only number we really see is 3. Now remember, there's 1s in front of all of these values, but it doesn't really do much for us to take it and write them out. So it's really just 3 times 1, so we're going to have a 3. And when we do times our a times our a times our a, and then our b times b times b, we've got 3a to the 3rd, b to the 3rd. Next one we have a squared times b times 5 times b squared times a. So the only number we see there is 5. Let's pull that one out. Then we have a squared times an a times a b squared times a b. Now we haven't talked about any ones with the exponents yet, but I want you to think about what does a squared really mean and what does b squared really mean. This is like saying 5 times a, right, because that's what a squared is, times an a, and then our b squared is the same thing as b times another b. So when we go ahead and put this all together, right, we've got our 5. We've got a times a times a is a to the 3rd. And then we've got our b times b times b, which is b to the 3rd. So we get that expression 5a to the 3rd, b to the 3rd. And that leads us into our product property. So this is one of the properties that you've probably learned in the past that we're just going to review. We've been doing it with all the problems above, but I never mentioned that it was a property that we were doing. Like when we do x times x, we get x squared. If we look back up here to this one, right? This is x to the first, x to the first, x to the first, and x to the first. When we multiply together, it's really like saying x to the 1 plus 1 plus 1 plus 1, which gives us that x to the fourth. Okay, so when we multiply two numbers with the same base, in this case we're using base a to represent any number, okay, but it's the same number, and then we've got exponents on those numbers, we can rewrite this as that single base, and then we are going to add the exponents together. So let's look at some examples. 2 to the third times 2 squared. If I was going to expand it, this would be like saying 2 times 2 times 2 times 2 times 2. But how many times are we really multiplying 2? That would be 5 times. So this is the same thing as saying it's 2 to the power of 3 plus 2, which is 2 to the fifth power. Now you could also take this a little bit further. 2 to the fifth power is like 2 times itself 5 times, which gives you 32. A to the seventh times a to the fourth, right? Nobody wants to take it and write out a times a times a times a times a times a times a, right? Is that getting a little repetitive hearing me say a over and over again? Okay, and then we're going to do it again, right? Times a times a times a times a. Well, that's no fun to do. So what we do then is we use this shortcut or the property. We know that they have the same base, they're both a. And since it's multiplying, we're going to do 7 plus 4, which gets us a to the 11th, which is what we get here, right? We're multiplying a times itself 11 times, but to write it like this would probably be a little bit easier. Now let's look here. We've got something else new popping in here. All right, we've got a negative 3 as an exponent. And although we're not reviewing negative exponents right at this moment, okay, this still works the same way. We have the same base, so we can add the exponents. So this would be like saying x to the negative third plus 8th. And then we just simplify that down. Negative 3 plus 8 is 5, so we have x to the fifth power. Okay, so they work exactly the same way. Even when they're negative exponents, you're still just adding them together when we multiply. All right, the next one says find the area. We have 8x to the third, and we have 4x squared. So again, we know that area is going to equal length times width. So our area here is going to be 4x squared times 8x to the third. And as we go through it, right, I can rearrange the order because it's multiplication. 4 times 8 times x squared times x to the third. 4 times 8 is going to be 32. X squared times x to the third is like x times x times x times x times x, or x to the fifth power. So our area is 32x to the fifth power square units. We're not worried about the units right now, though. All right, and then we've got another rectangle, 3a to the seventh and 5a squared. Again, our length, 3a to the seventh times 5a squared. This should equal our area. If we rearrange it, 3 times 5 times a to the seventh times a squared, we're going to get 3 times 5 is 15. A to the seventh times a squared should be a to the ninth power. And there is our area, 15a to the ninth. All right, so hopefully we're feeling good about these so far. I got just a couple for you to try now. It says find the product. I have 4x to the fifth times 6x to the negative second. So let's first write it out here. We have 4 times x to the fifth times 6 times x to the negative second. I'm going to rearrange them. Just go ahead and put our 4 and our 6 together, and then x to the fifth times x to the negative second, and that's 24 x to the 5 plus negative second, which is just 24x to the third power. Remember, you're adding those exponents together. The second one, we have 8x to the third y to the sixth times 4x squared y to the fourth. Again, we have 8 times 4 times x to the third times x squared times y to the sixth times y to the fourth. 8 times 4 is 32. X to the third times x squared would be like multiplying x 5 times. And y to the sixth times y to the fourth would be y to the 10th. And there is our answer. 32x to the fifth, y to the 10th. Now we've got 5a to the seventh, b to the eighth times a squared, b to the third. And remember, this one just has a 1 in front of it, even though we don't write it. So as we look to go here, I could treat that as 5 times 1 times a to the seventh times a squared times b to the eighth times b to the third. Well, 5 times 1 gives us 5. A to the seventh times a squared. How many times are we really multiplying a here? That would be a to the ninth power. And then b to the eighth, b to the third, that would be b to the 11th power. And there we go. And then we've got 3x to the sixth y times 6x to the negative second y to the seventh. Now remember, just because we have a negative exponent, we don't change what we're doing. Let's rearrange it here. We've got 3 times 6 times x to the sixth times x to the negative second times y to the seventh. So 3 times 6 gives us 18. X to the sixth times x to the negative second, well, that's like saying x to the 6 plus negative second, which would be x to the fourth, is correct. And then our y times y to the seventh, remember, this is like y to the first power. So this would be like 1 plus 7, which would be y to the eighth. We get 18x to the fourth, y to the eighth power. Then the last question is x to the third times x squared equal to x to the third plus x squared? And I think the easiest way to determine if those mean the same thing is to plug in a value for x. Let's let x equal, let's just say 2. We could use some other numbers here, but let's use 2. So if I take it here, I'm going to say 2 to the third times 2 squared should equal 2 to the third plus 2 squared. Okay, well this here, 2 to the third times 2 squared, we know is really the same thing as 2 to the fifth power, or you can multiply each of them out and get 8 times 4, which is going to give us 32 on the left side. But on the right side, if I have 2 to the third, that did give me 8, but now I'm adding 8 plus 4, and 8 plus 4 is only going to give us 12, so therefore those are not equal to each other, right? So it's important that we pay attention on those. We cannot combine this statement into one there when there is a plus. Okay, it's only when we have this can we turn it into a statement like that. All right, so that is the end of this section. Please check on Schoology for your homework. Okay, this is chapter 3-1.